you know, that's how you get your inverse function and then your points. Okay, so look, exponential functions, which is this side, this is the log function. We're going to graph both. You'll see that the values, okay, are just a switch as well. You're going to do a lot of them. By the way, for exponential functions, you guys are really good graphing them. All right? Now, the only parts you can kind of mess up are maybe domain and range, but that's kind of like, if that's your thing to mess up, that's your thing to mess up. Like, some of you are really good with it. Some of you guys are like, I don't get it. And then it takes you more time to process. So just pay attention to that, okay? All right, so here we go. F of x equal to 2x. I'll eventually put both of these into Desmos, especially when we get down to the bottom for domain and range and end behavior. You're going to graph them both on this little coordinate plane. Yeah, this coordinate system. Okay. This will make more sense to you later. Right now, you have a super basic exponential function. This f of x is equal to 2x. It's really, if I wanted to be really extra and put everything, you would have f of x is equal to, if say that you want to see the a, the b, x minus 0 plus 0. So if you really wanted to see that a, b, h, k, I gave you just f of x is equal to 2x. There really is an a value you're starting, right? 1. Your intercept, right? You have your h, which is your horizontal shift, and then your k, which is your vertical shift, okay? So this is what this looks like. You'll eventually get values. You'll get functions where this is like a 1/2 or 3/4. You'll have a 3, you'll have a 2 here. It's just the shift, okay? Eventually your packets will talk about anchor points, but you don't have your packets yet. But this is exactly this, just we were super extras with our 1s and 0s, okay? All right, you're going to go ahead. We'll learn about growth and decay as we write them, but it's based off the b value. If the b value is positive, it's a growth. If the b value is between 0 and 1, it's a decay. We'll see that when we're graphing more of them. Okay, you'll get good at it. Like I said, you guys are really, really good with these, okay? Okay, so f of x is equal to base 2x. It's an exponential function. What is my a value? Okay, you don't see it here, but I rewrote it to show everything. Your initial value, your start, what's your a value? It's 1, right? Okay, we're going to substitute in values. We're going to find our xy table because we're going to graph it. So let's just put in some negative values. So you could plug in like, we'll do -5 because we want a thorough graph, inverse graph. So we'll go -5, say -3, -1, 0, 2, and we go to 5. It might blow up huge though, you guys. Yeah. We're going to put in the calculator, so we're not solving it by hand. Okay, so that's why, yeah. Okay, so how do we find our y values? You could just grab a calculator and just substitute. So 2 to the -5 is 1/32, but I want a decimal. So SD, scientific decimal, and I get Are you guys okay? I can keep going? You know what you're okay. So if I make it a 3 to the -3rd power, 1/8, or, and by the way, they're supposed to be this small. We're not doing anything bad. Sorry. Go back. That's just 0.5, right? Okay. 0, and you get 1, put in the 2, it's 4, right? You already know that. And then plug in the 5, and I get 32. And afterwards, we'll go into Desmos. Okay, you're gonna go ahead. Obviously, the critical points, x-intercepts, y-intercepts. This is all Desmos. We'll look at Desmos here as well. All right. So if now I decide to substitute those values, right? Plot them. So -5, 1, 2, 3, 4, 5 is like 300. I'm just gonna put a dot here. Barely. Whoops, -3. Sorry. Here. -1. 0 is 1. Oh, okay, we can't go by ones. What do you guys want to go to? 5. 2 goes to 4. 5 goes to 32. What do you guys want? Go by these, because I know it's not here, but if we did 3, it would be 8, right? So I don't go by one. What if we go by 2s? 2, 4, 6. That's 20, 32. What if we go by 3s? 3, 6, 9. Yeah, you want to go by 3s? Yeah? Okay, so if we go by 3s, 3, 6, 9, 12, 15, 18, right? 21, 24, 27. This is 30. So this is 33, so we can fit it. Okay, 0, 1 would be here. 2, 4. 3, 8. 5, 32. Okay, here's the thing with, all right, right here, as it's approaching your negative x values, it's getting close, but it's never gonna touch. So like if this is my x-axis, right? The line is like dropping. It's supposed to get really close, but it never crosses, ever. Okay, so don't let it cross, don't let it fall below. Someone did not put this whole thing. Okay, so I'm gonna have to shut this off or turn off the video because I need to type into Desmos. Because then we'll do domain, range, and behavior, and the critical points, your x, y intercept. And then we're gonna talk about an anchor point. I'll highlight a point, and I'll call it an anchor point because that's what your packets talk about. Some of you, you'll get it, you'll like it, and then some of you, you'll do well graphing without the term anchor point. So if it suits you, fabulous. If it doesn't, I was never taught it, so I mean, and I get them, so it just, it's not, you're not going to get tested off what's the anchor point. Okay, turn it off. Yeah. Okay, if we